All right, so looking at number 3 here, I've got a 6-volt source that's going through a parallel network with one branch and lots of series. So if everything is starting here, I'm just going to kind of follow the circle with my fingers, and it's going to split and then rejoin. So it's really just a parallel network with a series thrown in. So the first thing I'm going to do is find the equivalent resistance because that's easy. So 10 plus 20 plus 30 is 60. So I've got a 200 ohm resistor and a 60 ohm resistor in parallel. If I do that, 200 over, I get 46.1. So it doesn't work out to a normal number, which is perfectly okay. As a matter of fact, that's pretty much the normal. Now the battery is 6 volts, and so we can pretty quickly figure out the current through here. 6 divided by 46.1 is about 130 milliamp. So now we have to decide what to do next. And to me, the first thing I do is I see, okay, I've got all these resistances given to me. So I'm going to kind of fill out the outside of this first. Looks like I was given 200 here. R2, I was given 10. R3, I was given 20. And R4, I was given 30. So that was easy. And let's see. From here, I have to choose what's easiest. And to me, what's easiest right now is, okay, I've got a 200 ohm resistor here that's all by itself. And I know that this side here and this side here are the same height above the ground, the same voltage, the same potential. So R1 and this whole series together, although not each individual resistor, are going to be at 6 volts. So what's what we know? I know, like, okay, I've got 6 volts here and it's 200 ohms. Okay, well, 6 ohms, or 600 divided by 200 is 0.03. Okay. Well, that means 0.1, 100 milliamps, is shared between here. And as a matter of fact, each one of them has 0.1 milliamp because all of the electrons that went through here had to end up here, and they had to go through this one, and they go through this next one, R4. And so if I put in 0.1 here, the only thing option is that 0.1 came out. You know, if 0.03 is going this way, that means 0.1 is coming this way because I need 0.13 total. If that makes sense, what's going on? Well, in other words, that just means multiply the voltages, 1, 2, 3, I could type, and take a look. 1 plus 2 plus 3 equals 6, which is also equal to 6. So this problem works out pretty easily.